So this project, as you can see from the title, was about sort of novel formulations, really. So it's been funded by Sugar Research Australia, Australian Government, DAWE, and managed by CRDC, and I'm from the Department of Agriculture and Fisheries in Queensland, in this state. So the team, and I've missed out a couple of important components of this, which I'll mention at the end. I'm from the Department of Agriculture and Fisheries. On this team is myself, Ian Phillips, Brianna Smith, Ben Hunter. Talita Bailey was a contributor. Armando Navas is the engineer who's done a lot of the work on our gear that we use. From University of Queensland, Suzanne Schmidt, Bronwyn Laycock, Steve Pratt, Ian Levitt, Richard Bracken, Aidan Chin, Nicole Robinson and Maren Westerman. They're from two different teams at UQ. And I need to mention HCPSL and Pharmacist for their assistance with the field trials, which I'm not going to talk much about, so I guess that's why I forgot to put them on the list there, because they're still continuing. So there's really a couple of objectives that this project was about. It's can a technology be identified capable of efficiently meeting in-season nitrogen supply expectations under cane production system conditions? And we wanted to look at where there are opportunities for close to source mitigation measures to deal with nitrogen export off-site, because the best place to intercept nitrogen is at the source before it gets diluted. Someone earlier said the solution to pollution is dilution. I think that's old view now, but right. So can we increase the period of effect of nitrification inhibitors? So they're the inhibitors that are stopping ammonia converting to nitrate via encapsulation. And can we use, and when I talk about polymers, generally I'm talking about things that are biodegradable, because I'm also concerned, like a lot of other people, about the use of polyethylene for encapsulation because of the generation of microplastics. So those are a couple of things we're targeting. And we're also looking at using vegetated filter strips in that close to source mitigation approach. Now, because, and this is going to be comforting or discomforting to some, we're not promoting anyone's product. We're basically going from novel materials to enterprise scale trials, and that's a big ask in the time scale of this project. So it involves process trials in the lab, to screen out a range of different products and choose the ones that we want to use. I'll talk more about that. Growth accelerator trials, that's my pompous, name for a large growth cabinet with some kit in it, which I'll show you as we go. Rainfall simulation trials, small scale instrumented field trials, and then at the other end of the scale, those enterprise scales that are continuing. So let's just deal with the lab scale stuff first up. I'm really only able to cover about 1% of what we've done. So I'll just try and give you a feel for what we did. This is the gas manifold we used and microdialysis probes installed in some soil. They've been very helpful technologies, but not when I press the button like that. Right. Okay, so this is about process investigations. We had a lot of potential approaches that we could take. We wanted to zero in on the ones with the highest potential. So we tested 18 initial inhibitor formulations, and we could have done more. Most of those were formulated by our UQ polymer colleagues at University of Queensland team in consultation with us, and they did some water release studies and some other process trials. And then out of this work, and I'll show you why, we progressed some of these materials to other trials subsequently. Okay, so the sorts of things we do in those reaction vessels, we put the treatments into those reaction vessels. We have 31 channels to play with. When we were first getting used to it, we were only running about 20 channels. Each channel will have some soil, it'd have a treatment, or it might be a control, it'd have a probe for the microdialysis. And this is some of the results we got for the black clay soil. And you can see that we have week 1, week 2, week 3, week 4, week 5. That's cumulate microdialysis extracted ammonium. See the yellow line on polymer B, DMPP. On week 10, we come up with a difference that shows that it's got significantly higher extraction, retention of ammonia, that's how you should think about that, than DMPP alone added to that particular soil. So that makes that a candidate for further study. Likewise, we might have not have had a significant difference with polymer A, but there's enough there that it made us interested in doing some more work with the material. This is a separate soil, another soil, the McNade soil from outside Ingham. We have here days 0 to 60 in this particular trial, and each of those is replicated. We've got the LSD there. And you can see that the two lowest lines on the graph, we have a couple of polymer blends that are outperforming DMPP by itself at about 50 days. Now, okay, you'd say, well, that's not quite significant relative to DMPP, but the issue is here that DMP's efficacy falls to the level of the control. It's not significantly different from the control at that point, whereas the others still are. So that's, once again, enough for us to take that on to the next step in the trials. This is a different soil. So this actually looks like not much work. It's a lot of work, a lot of analyses for each of these. So this is a red clay soil, urea addition versus no addition, and you can see that one of our polymers has ended up with some better performance in terms of retaining ammonia at 85 days. The problem is with the trials, we tend to look at them, and if trends are still changing, we keep them going. So we've started running a lot of trials out to 85 days now. Now, one of the great interests, of course, and for good reason, in using nitrification inhibitors is the potential to decrease nitrous oxide emission. And this is the same data, the same trial, but we have our online real-time gas analysis kit connected to this. And one of the things we're analysing is nitrous oxide. And you can see here that the high peak is urea addition by itself. Bumping along the bottom is solution DMPP added to that system, and our encapsulated one is in between. Well, why is our encapsulated one in between? It's a slow release form of DMPP, whereas the entirety of the solution DMPP added in aqueous solution to that soil is acting immediately, and most of your nitrous oxide emissions are going to happen within the first couple of weeks. So that's actually one of the downsides of making a slow-release DMPP, but you can increase your rate, I suppose. One of my great interests in looking at this as a scientist was I've wondered, do these DMPP additions have an impact on the microbial communities within the soils in the longer term? We've done some work with metagenomics or microbial community work and shown that over time, say 20 weeks, we did get measurable differences in the community, but we didn't really know what that meant in terms of functionality. This data suggests that in terms of gross respiration from those soils, the addition of the DMPP didn't really have an effect on that. So that's reassuring, I think. Okay. So the next type of study in that chain, in that sort of continuum, was our growth accelerator trials. And that's really just a very big growth chain, but made out of a freight container. We put our pots into it. We have a gantry to automatically water. We have a robotic thing to scan the plants in 3D. And we're able to, and this is one of the things we've developed. You develop know-how in these projects, and we've got better and better and better at this. So, right, what do we get out of that? We found that in this particular trial, solution DMPP, polymer A and another polymer increased our nitrogen uptake, actually a blend of polymers, increased our nitrogen uptake by sugarcane in 2 sugarcane growing soils. So there's a couple of soils in that particular trial. We decreased leaching losses very significantly. I'll show you the graphs for this in a moment. I just want you to pick up the concepts. Differentiation was poor between the solution DMPP and our products. That's something of a trial failure. And the reason being, I'll just zip back a few slides. Right, 50 days, look at that change. We leached that system. That was a leached pot trial at 29 days. There was no differentiation between our treatments at that point. That's what you get in hindsight. However, our approach now is to repeat that trial. We're 80 days into the next trial, doing that again. So this is showing that we got this increase in nitrogen uptake in that trial. Relative to urea only, and the controls there for reference as well. That's no nitrogen addition, and you can see that we did have not much differentiation between them, but they all seem to work, so good and bad. In terms of nitrogen leaching, for one soil they all worked about as effectively as each other, and yet there was differentiation in the wrong direction. The DMP solution, DMPP performed better in that one. That's because there's more of it in the active state, more released into solution because it's all added there, and we didn't give it enough time for that difference to evolve. So that's in progress. Let's see what happens. One of the outputs was this novel 3D scanning technology that we've then actually got a paper in review. Looks like it won't be too hard to get through, showing that we can measure dry matter production on a daily basis if we want to spend the processing time in that trial. This is what the data looks like though. Imagine you move a camera around to 360 different positions automatically over that, and then you're able to stitch those point clouds together. You get, I don't know, each image is like 3 gigabytes, and then you join them up and you process them, and you can use an AI technique to segment out the plant and measure the size of the plant automatically. Right, a rainfall simulation. This is about this close to source mitigation. Not a great result. Okay, so what happened here was we had this apparatus. We've had several tries at this over the years to get this to work. We have a lot of success measuring losses of phosphorus. When you have to include nitrogen transformations in the experiment, it gets complicated. So we had an initial trial connected to this from another project that we got information that suggested that using the DMPP in the soil, we could have a positive result. It looked like a significant effect, but there were some things we weren't comfortable with in that. So we're repeating that with a high ammonia preference zeolite produced for us by Ian McKinnon's team at QUT, and a DMP and DMPP both in an encapsulated form and as solution DMPP additions. Our big problem was that in trying to cure the problems from the previous trial, we caused another one. So we've got some distance to go on that, I'm afraid. So I think we can do it again, but I think we've run out of time in this project. Right, so that's the result from the previous trial, and I'm not really that happy with it, but you can see that we have ammonium sulfate at 150 runoff mineral N milligrams, and compare that to the background. When you add DMPP, it appeared to decrease those losses dramatically, but I was worried about losses that were happening before we even put it onto the rainfall simulator as we were allowing time to react. So we changed what we did, and we ended up with no significant differences across the entire trial, which is pretty disappointing. Okay, so small-scale field trial was the next thing we did with a model plant, not with sugarcane. So this trial was run at the Tor Street site, and we were very careful how we applied it. We removed the soil from those slots, we put our treatments in, we put our encapsulated forms of DMPP into the slots, and we forced leaching. So the growth accelerator trials had a leaching challenge. Our field trial on this scale had a leaching challenge. So we're applying water at fairly high rates to push the nitrogen through the system using solid sit irrigation. What we found was that one of our inhibitor treatments demonstrated a benefit relative to urea alone, and that particular blend produced about a 19% increase in uptake. And however, some of the other rates of that particular formulation didn't perform as well. They didn't poke their heads up above the variation, but I guess that's what you get sometimes. I'm going to talk about this later, and actually in the unexpurgated version of the talk, I had a big description of how I'd optimise this, but I can't do that, I'm afraid. Righto, so I've thrown in there a treatment which outstrips everything, and that's because after every cut in that trial, we applied 50 kilograms of N per hectare to get maximal production. And because it was so heavily leached, everything else was a long way below that. But this urea polymer B on the right-hand side was about 20% higher in uptake than the urea only there. All right, so on to the field scale cane trials in the north. They're in progress. Final harvests yet to be collected from the northern trials. Formulations work well with conventional spreaders, and I'll show you that in a moment. Despite 12 months of site rundown at each site, we haven't got responsiveness to N, which is exactly what Lucas, I think, was talking about. So hoping that our next harvests do. So what I mean is that our control, for example, with no N addition was producing 18 tonnes of dry matter per hectare on the fourth return at reasonable CCS. So, and that's with no N addition. So I think that hopefully we can do better this next cut. So I'm looking at the soil profiles, and my offsider Ian Phillips said that I couldn't talk about it because it wasn't clear enough yet, so we need some responsive N years to see what's happening. But it looked like something was happening in terms of nitrogen leaching and retention in the profile. However, the guys running the automatic spreader, the variable rate spreaders, were very happy with these materials, and I think that's critical. It's something we under-emphasise. In the bins, the materials don't seem to separate, and they ran through the machine quite well. So tailoring delivery, there is this opportunity of using several different parameters, the types of polymers, how we blend them. We really only have tried out one formulation of each one of these polymers so far, and we can change a lot of parameters. So there's that opportunity to trial and select formulation parameters, to play with the system so that we're providing an effective dose within an appropriate diffusion distance of the end source. What do we know? Matrix encapsulated nitrification inhibitors extend inhibitor efficacy in some soils, and that is soil dependent. So we can make that system better by optimising it. We also know that these materials are biodegradable and they can perform well in this role. That's a decent finding. However, I think that we need to consider with some of these soils with CECs around the 3 mark that the use of inhibitor alone may not be the complete solution. When you've got a system where you can make ammonia leach with so much water pushing it down through the profile. So we're seeking to translate findings into proven NUE increases in the field, and that really requires some more optimisation, validation, and then you have to make these materials available to the producer and incorporate it into 6ES. So we're looking at all sorts of strategies that we might be able to do that. Outputs, problems to solve, several formulations identified. They're ripe for optimisation. I think they have applications beyond the sugar industry, and that's pretty interesting, and maybe that's a way to push the work forward. So we've completed a series of presentations to sugar producers and agri-industry in northern production areas, partnering with Fertiliser Australia. Thank you very much, Fertiliser Australia. And I think we've, in the course of the project, improved our understanding and being able to publish some stuff that hopefully increases understanding around delivery of products, agrochemicals from matrix encapsulation, and a few other questions. And we've developed a novel method for measuring nutrient uptake profiles over time, and that's in review actually more than in press. So, yeah. And I'll probably leave it for questions there.